Good evening, everyone. Welcome to NPTL tutorial session on the course Classics in Total Synthesis, which is taken by Professor Krishna P. Kaliappan, Department of Chemistry, IIT Bombay. Myself, Sreelekshmi S. I am the NPTL TA for this course, and I am a PhD scholar in IIT Bombay in the Department of Chemistry. So, this will be our last tutorial session for this course Classics in Total Synthesis. So far, we have covered all the lectures, like a brief summary of all the lectures which the professor has taught in previous classes. That is 12 week. It was a 12-week course, and we have completed more than 50 natural products total synthesis and various named reactions, their discussion, and all the assignment questions, their answers, and other general questions related to the assignment questions and the reactions that we came across. So I hope this journey was helpful to you. So today we will be discussing the week 12 assignment which is remaining for the discussion. So we have seen the discussion about various natural products, starting from natural products having three-membered rings, four-membered rings, five-membered rings, and various other alkaloids, steroids, and like that several natural products we have seen. So if I am going through all that in a quick session, so as told, the first lectures was about the introduction to this course and introduction to various technical terms related to organic synthesis. Then we started with the total synthesis of illudin M and C, which is having three-membered ring. Then FR 900848, and then we came to four-membered ring, and a large amount of time we spent for the discussion on cubanes, and then followed by that N-andric acid, which is also having four-membered rings. Then penicillin, which is having a four-membered ring, that is beta-lactam ring. Then tinomycin, which is a derivative of penicillin. Then prostaglandins, that is having five-membered rings. Then our discussion. Okay, these are the assignment questions. Then the next discussion was about prostaglandins, then biotin, lactacystin. Then we came to triquinanes, like many triquinanes total synthesis we have seen, like linear triquinanes, angular triquinanes, like isocommines, then isocommine and sulfifurfol, then hyrostine and capnellane, which are linear triquinanes. So these are the some of the questions which we have discussed previously, other than the assignment questions. Then other triquinanes by radical cyclization, then triquinanes by photochemical reaction, and several methods to construct the triquinane core skeleton. Then triquinanes by thermal metathesis, that where we saw a famous Mehta's approach as well for the construction of triquinanes. And then Poisson-Kahn reaction and ring expansion reaction, Nazarov cyclization for the construction of triquinanes. So these are some of the examples which we discussed previously. I think I have lost my network connection. Oh, I hope it is visible now. If there is any problem in the visibility of the slides, do let me know. Then our discussion moved towards the total synthesis of longifolin, carpanon and mevinolin, then gibberellic acid. Okay, then the discussion was about some other natural products like reserpine, yohimbine, quinine, dendrobin, morphine. These are the alkaloids which we have seen various total synthesis for these alkaloids. Then we have seen the total synthesis of methyl homosecodafniphyllate and secodafniphyllane, then lysergic acid, galantamine, epibactidine. We have discussed a variety of reactions as well. Then we have seen the total synthesis of swainsonin, staurosporin, mansamine, progesterone, and other steroids. Then we had a discussion on eastron, total synthesis of eastron, and a large amount of time was spent for the total discussion, total synthesis of taxol. Various total synthetic approaches towards taxol was discussed. Then the next session was for eleuthrobin and forbol, then periplanon, discodermalide. And then the last lecture, the last week's lectures was about epothylones, vinomycin on B2, and saragosic acid. So today we will be discussing. So we can start the discussion on week 12 assignment. So the first question is identify the major product in the following transformation. So this particular compound, that is this ketone attached with this chiral auxiliary on treatment with NHMDS and methyladenine THF in the first step, and then in the second step with lithium aluminum hydride in diethyl ether, what will be the major product? That is, after these two steps, what we will get the final product out of these four options. Okay, so here what will be happening? Let me take the pointer. So, first, while treating with this so this is our starting material, this second compound. So, by treating it with NaHMDS in THF and methyl iodide, this acidic proton get abstracted, and here a negative charge will be generated, which can attack this methyl group, which is the electrophile, and I minus will be leaving. So here it will come one methyl group, and the stereochemistry of the corresponding methyl group will be controlled by this chiral auxiliary. So since this benzyl group is present in this above position, that is beta phase, this carbanion will be attacking methyl group from the alpha phase, that is below phase, due to the steric hindrance created by this benzyl group. So this will since this is beta, the methyl group will be alpha as given here. Now, while treating this particular compound with lithium aluminum hydride in diethyl ether, this chiral auxiliary will get eliminated. That is, reduction will occur and this will be converted into corresponding alcohol. So, we will get this product. So, the correct answer is option B. So, first, proton abstraction from of this acidic proton and quenching it with methyl iodide. Then LAH reduction will eliminate this chiral auxiliary along with reduction of this particular C double bond O to get the CH2OH. Now, moving to the second question, what is a major product in the following transformation? So, these two compounds are first treated with LDA in THF and then in the second step with PPTS and methanol. So, out of the four options, which will be the product resulting after these two steps? So, PPTS is pyridinium paratoluene sulfonate. It is generally used for deprotection of this ethers or silyl ethers or tetrahydropyrenyl ethers. When a substrate is unstable to stronger acids and catalysts, we can use PPTS for the deprotection. So from that itself, it is clear which will be the answer. So here, what will be happening? Similar to the previous case, by treating this ketone with LDA, anion will be generated at this position and it will attack this electrophilic carbonyl carbon center of this alcohol, and as a result here we will get aldehyde and here we will get alcohol. So in the first step we will be getting this alcohol with this corresponding stereochemistry. And then what is happening by treating with this PPTS? This ether group will get deprotected and we will get two hydroxyl groups. So the resulting product will be a triol with this particular stereochemistry. So the correct answer is option C. So it is clear from this that this minus charge will be go and attacking this aldehyde from a position which is opposite to this particular methyl group. So this alcohol will be coming at this alpha side and this methyl group will also be coming at the alpha side. And this is already existing chirality, that is this methyl group is in the beta side. And then in the second step, PPTS will deprotect this group, giving this diol here and this triol after this electrophilic, this anion addition on this electrophile, that is aldehyde. So the correct answer is option C. Moving to the next question, identify the major product in the following transformation. So this particular enamine upon treatment with this ethyl carbonyl chloride and this hydrolysis, what will be the major product after these two steps? So here what will be happening is, first when we treat this particular compound with this EtCOCl, what will be happening? This acylation will be taking place with this enamine. So this nitrogen lone pair will migrate to here and this bond will go and attack this carbon center and this Cl minus will be leaving out. So it will be here double bond will come here, this 2 methyl group will be there and this carbon will be attached to this C double bond of Et. So this is type of an acylation reaction. So here it will be N plus and that will be neutralized with this eliminated Cl minus. Then on hydrolysis what will be happening? This will be converted into corresponding, that is this is now iminium ion. So iminium ion on hydrolysis will give us aldehyde. So this the C double bond N plus will be converted into C double bond O, that is this aldehyde will be generated. So the correct answer is option B. Okay, now moving on to the next question. Identify the right sequence of reagent that results in the following transformation given below. That is, this corresponding compound is converted into this OH, and this hydroxyl group here is converted into this CH2 group. So, what will be the sequence, correct sequence of reagents? That is Wittig reagent, Dibalash, then this Swan oxidation. So, what will be the correct sequence to do these three reactions: Wittig reaction, Dibalash reduction, and Swan oxidation? Okay, so moving to this question. So here the correct sequence of reaction is first Swan oxidation, then Wittig reaction, and then Diballage reduction. So starting from here, this is our starting compound. So Swan oxidation on this compound will convert this free alcoholic group into aldehyde. So because these two are protected with this fuel oil ester, so this hydroxyl group is free and that will be converted into corresponding aldehyde, oxidized into aldehyde under Swan oxidation condition. Then upon treatment with this Wittig reagent, this aldehyde will undergo homologation. So we are treating with methyl Wittig. So one carbon homologation will be taking place and we will get this alkene here. So then this alkene upon Diballage reduction, we will be getting this fuel oil ester group will be getting reduced and or deproducted we can see, and we will get this diol. So this is our product. So from here to here, this is the correct sequence of reaction. Swan oxidation of this aldehyde, then Wittig reaction to get this corresponding alkene, and then this fuel oil ester is converted into corresponding hydroxyl group by using diballage. So this is the correct sequence of reaction. Moving to the next question, identify the major product of the following transformation. So this particular alkene upon treatment with LDA and HMPA in presence of this allyl bromide, what will be the product? What will be the major product out of this four options? So answer I have already given here. The correct answer is option C. Now how it is forming? Okay, so here how this is actually happening is that this LDA will basically abstract a proton from this methyl group. So what will happen? Here a negative charge will be generated and that will be shifted to here, and then this particular alkene will go and attack this allyl bromide. It will be shifted to here and bromine will be eliminated. So that is the mechanism. That is how this is forming. So it is given here. This proton is abstracted from this methyl crotonate by LDA. That anion will shift to here. Then this double bond will go and attack this carbon, and this will be shifted to here, and this bromide will eliminate to give this alpha, beta, gamma unsaturated carboxylic ester. That is alpha, beta, gamma unsaturated carboxylic ester. So that is the fifth question. Now moving to the next question. Identify the major product formed in the following transformation. So this particular compound upon treatment with rhodium chloride and ethanol in the first step and then heating with this diethylamine, what will be the major product after these two steps? Okay, so here the correct answer is option D. So upon treatment with this rhodium chloride and ethanol, actually the isomerization of this particular alkene is taking place. That is, this double bond is getting isomerized to this position. This terminal alkene is converting into this internal alkene, and we are getting this corresponding product in the first step. Then, upon heating it at 210 degrees Celsius with diethylamine, what will be happening? This is a 3,3 sigma tropic rearrangement, that is, Claisen rearrangement is taking place. So, it is like this is 1, this is 2, this is 3, and then this is 1, this is 2, and this is 3. So, it is like this bond will go and attack at this 3 3 bond will be forming, and this bond will be shifted to here, this will be shifted to here. So here it will be OH will be forming when it is like it will be in enol form, then it will aromatize to, it will be in keto form, then it will aromatize to this alcohol. So this is the step. So in the first step, this isomerization of this alkene is taking place to get this internal alkene, and then in the next step, this Claisen rearrangement, that is 3 3 sigma tropic rearrangement, will result in this product. So the correct answer is option D. Moving to the seventh question, identify the major product formed in the reaction given below. So this particular compound, upon treatment with HCl and methanol, what will be the product out of these four options? Okay, so here what is happening, by treating with this HCl and methanol, this group will get deprotected, so it will be a diol at this position. This 1,2 diol will be forming. Then what will happen is that this particular hydroxyl group and this particular hydroxyl group will protect this ketone as a ketyl, resulting in this particular compound. So these two steps are taking place simultaneously in this reaction. So what is happening? This group will get deprotected and there will be two free hydroxyl groups other than the hydroxyl groups present here. Then this particular hydroxyl group and this particular hydroxyl group, that is 1 3 1 2 3 1 3 diol will protect this ketone as this ketyl. So see, as this ketyl, and we will be getting this corresponding product. This is 1 2 3. So these two hydroxyl groups are protecting that particular ketone as this ketyl, and we will be getting this product. So the correct answer is option A. It is 1 3 protection and this deprotection as well in the same port. Moving to the next question, identify the major product in the following transformation. This particular compound, upon treatment with NaBH4 and isopropanol, which will be the resulting product out of this four options given here. So here what is happening is that by treating with this NaBH4 in isopropanol, this quinone will get aromatized, and that is this both this ketone will get reduced, complete reduction of both this ketone under NaBH4 isopropanol condition, and we will be getting this completely aromatized product. So this is a complete reduction of these two ketones. So the correct answer is option A. Moving to the second last question, identify the major product of the following reaction. So, okay, here I have already given the answer. So, this particular compound upon treatment with this trimethyl aluminum and sodium periodate, what will be the major product out of this four options given here? So here as given here, what will be happening is that this one of the methyl group from this trimethyl aluminum will go and attack this epoxide and open this epoxide forming this diol. So this diol will be forming, and this is like this methyl group will be attacking the face opposite from that of the epoxide. So methyl group will come alpha, that is below, and epoxide will be obviously in the beta phase, that is above phase. Then upon treatment with the sodium periodate, this diol cleavage will take place, and here one aldehyde will be forming. So that is this trimethyl aluminum mediated epoxide opening, and then this sodium periodate mediated cleavage of this diol to get this aldehyde. So the correct answer is option D. Moving to the last question of week 12 assignment, identify the major product in the below reaction. That is, this particular compound upon treatment with this dimethyl amine in methanol, and in the second step with this compound dimethoxy diethyl carbon and tosyl hydroxide paratoluene sulfonic acid in 90 percentage, with 90 percentage of yield. That is this, these are the yields that they have mentioned, 97 percentage and 90 percentage. So what will be this major product after this reaction? So here what is happening is that this dimethylamine will open this particular lactone, that is, this will attack, this nitrogen lone pairs will attack this carbonyl carbon, and this will be opened, resulting in a triol. Then this 1,2-diol will be protected by this particular protecting group as this acetyl. So this will be the corresponding product. So the correct answer for this question is option B. This opening with to form this opening of this lactone to form this amide, and then protection of this diol in the second step. So that was the 10 questions of assignment 12. So today's session we have planned for 1 hour. I'll give you some couple of minutes to go through these problems and to see whether you have any doubts or any clarification is needed. Okay, so with this, we will be finishing our tutorial sessions. So we had in total 13 tutorial sessions, including today's 1 hour session as well. So I hope all these tutorial sessions was helpful to you. So all the videos of recording videos of this 13 tutorial sessions will be available in YouTube, and this slides also will be made available to you, and this link for this YouTube videos as well as the slides can be will be accessible to you in the NPTEL Swayam portal, and you may go through this and you can ask any doubts or clarifications or suggestions in YouTube or NPTEL portal as well. So thank you for joining and thank you for listening. So we will be winding up the tutorial session. Thank you.